Right. Hi, everyone. I'm going to be talking today about new directions for mechanism design, how we can do better experiments and have a better understanding of the design space so that we can more effectively create some of the mechanisms that Josh was just telling us about, and whatever else you can imagine. So I'm speaking through the Mechanism Institute, which is a new project that I started dedicated to this problem, and doing so practically, but also with the kind of collaboration and contributions of the academic and more theoretical side, but really linking that to practical experiments. And so the fundamental premise here is that crypto gives us a new substrate on which to do these sorts of experiments. So previously, what you would do through bureaucracy, law, government, you can now do through code. And not only can massive centralized players who have lots of capital run these sorts of experiments, but everybody can, right? Even if you're not technical, you might be able to use a software interface to click, 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 configure something, and launch an experiment that manifests some dream you have of how the economy or how some political system should work. So I'll pause there and give you 60 seconds to turn to your neighbor and tell them 30 seconds each, maybe one idea you've had about how crypto can change the way something works. Something small, something big. I'm sure everybody's thought of some wacky idea of how blockchains can improve the world. So go ahead.
To me, the main thing is
Switch partners and switch people talking.
makes sense.
Okay. Please wrap it up. Last 5 seconds. All right, and back to so, I hope that kind of triggered maybe the moment when you got into crypto, the moment you understood what blockchain was, what a smart contract was, and you kind of came up with that crazy idea of, oh wow, this could solve this problem I've been having at work, or this industry's having, or that my friend's trying to do something together are having. And I want you to hold that in your mind as we kind of walk through this design space and try to feel out how what experiments have gone on so far could maybe reignite that dream. And so, right now, maybe you have this great idea, but there's sort of a problem with getting it into reality, right? So, one, not many people understand the breadth of this design space, right? So, there's people who call themselves token engineers, or crypto economists, or mechanism designers, but anyone can really call themselves that, right? There's a really wide range in what that actually means, and you might be talking to someone who is a cybernetics enthusiast, or who is a coordination nerd, or who is very into governance, or who's a total finance nerd, right? Financial engineer. So it can just mean lots of things, and it's a high crossover of different disciplines, right? And then also, so far in the space, maybe you have some cool, interesting idea that could actually improve things, like the ones that we heard from Josh, but the ones that are going to take off, like we heard from the audience, are flipping NFTs, right? So these things end up crowding up the space and making a lot of us jaded and maybe even leaving the space because we get upset with what's actually going on compared to what's possible. Also it's just easier, from the perspective of a project, let's say that raised money, they're going to start to be risk averse. Maybe they have one thing they're trying to innovate on, like they're bringing some product to market, So they're going to go really conservative of their governance and just copy paste, what Uniswap did. Yeah, and lastly, there's not really this nice bridge, I think, between the people thinking deeply about this from all these different disciplinary perspectives and the people that are actually out in the field building, right? And so we have this like messy ecosystem right now of consultants, VCs, and startups and DAOs, which are later stage startups in some cases, really struggling to figure these things out on the fly. And so that's the premise for why I think we need to basically build more knowledge and experimentation around this space. And that's what we've been doing. So I'll kind of go through some of the outputs that we've already created because I think that they can actually immediately be practical and you can check them out yourself. And so these are the different modalities that we're using at the moment for exploring this space. And so we started with the mechanism library, which I'll walk through in a moment, which shows you kind of what's gone on so far in the design space. And everything's still a work in progress, but this is already live. We also are doing various experiments on formalizing a design methodology for mechanism design or crypto economics that takes inspiration from different places and combines them into kind of an elegant framework that is fairly easy to use, as well as looking at modeling, so financial models, simulations, and then also, of course, AI. Why not? So we'll get into the applied research at the end as well, but we'll start with the library. Yeah, so if you go to mechanism.institute, we already have the library up. And so we have this very simplistic schema right now for how you can tag different kinds of mechanisms. And so the simplest way, I think, of starting is with value transfer. So this is basically different mechanisms for moving value from between parties. And this is just a small sampling of them. We have plenty more there. And we can also, I'll leave time so that we can click into these. We can go to the site and talk through any mechanisms you think are interesting. But you can see that some mechanisms obviously cover two of these tags. Like for example, the Nouns DAO came up with the concept of continuous auctions, which basically uses, I think, Zora's auction house on top of a fork of Compound's governance that uses NFTs for voting. And so this is an example of a mechanism that is used to orchestrate a purchase. So you're purchasing an NFT, it sells one NFT per day. And then also it's a fundraising mechanism because that's what's financing the organization. Because in some cases you're not getting pure utility out of the purchase, but an expectation of future utility. And in that case, it's also a governance primitive. Next we have fundraising. So there's been a lot of experiments here. A few that have gotten very popular, but I think many more that have not gotten popular that are buried in forums and prototypes. And so I think a lot of these are worth taking a look at because if you look at the projects that have succeeded today with fundraising, most have just gone the full conservative route, right? Privately raising from VCs. And these more experimental measures have had less traction, largely because of regulatory reasons. But I think there's an in-between there that people have to go deeper on. Yeah, then we have signaling mechanisms. So these have to do with information, curation of information, incentivizing the surfacing of truth in different ways. Governance is pretty self-explanatory. And I think one insight here that I'll touch back on later is the need for algorithmic governance mechanisms and also incentivized governance mechanisms. Because today, there's kind of this naive token-weighted voting, which is deeper in the library, which most projects are using, but there's plenty of critiques out there. And I think what's very interesting to look at is these more algorithmic approaches to governance, like conviction voting, where different people are staking their preferences, and then over time, the protocol or the algorithm is making the decisions on behalf of the group. So you don't have to explicitly do so, like most protocols or systems do today, kind of borrowing from let's say government and corporate governance, where it's yes, no voting on proposals. Yeah, next are market mechanisms, so things like auctions, matching systems, currency design primitives. And lastly, value capture. So how do systems that are designed that somehow bootstrap resources, facilitate some transfers of values between different parties, somehow govern that? How do these systems return value back to different stakeholders? Right, so we can dive back into specific mechanisms. I'm sure there's a lot of questions there later. But I will go next to cover some of the design modalities, design methodologies we've been looking at. And so one space that I haven't heard talked a lot about in crypto is actual like the game design literature. So there's really extensive literature from video game designers and board game designers on how do you go about like building a system with certain tools that then various players are going to participate in, and how do you predict the emergent outcomes that will have. And so I think that one of the most heavily cited papers in this space is this paper called the MDA framework, the Mechanics, Dynamics, Aesthetics framework. And the idea is that the game designer has control, or the perspective they have is on the mechanics of the game, right? So what we've been calling in crypto the mechanisms, or the coordination primitives. And so that's what the mechanism designer or the game builder sees, right? But then when you actually run the game, you have these higher order dynamics that emerge. That's the runtime behavior of the game, which they call the dynamics. And so these, you could predict them, and you could, through looking at the experiments that have happened so far, start to have a mapping between combinations of mechanisms and the dynamics you expect to emerge. And then lastly, the thing that's further away from the designer is the actual impact that the game has. And so in this context, they're thinking about literally games that people are playing to have fun. And so they call this aesthetics. Like, what is that like experiential thing that the human feels when they play the game? And so right now we're working on adapting this model to crypto and looking at the third side of it. The third step is more so the impact that the game has. Because if you're designing designing a universal liquidity protocol, the impact you want to have is like very low slippage trades. If you're making a refi protocol, maybe the impact that you want to have is reducing carbon emissions. And so the player, we have to note, has the opposite perspective. They just see the experience, so the impact that something's happened, and they might have no understanding of the mechanics. And so there's a lot more in this paper that the game design industry has found useful that I think we can adapt for our needs. And this is just an example that we put together of how you could take something like the business model canvas and then map something like the mechanics, dynamics, impact framework onto that when you're designing some sort of crypto economic system. So you can think about the technological platforms you'll be using, the primitives, which we have mapped out in the library, and various components, and how that then you expect that will result in certain dynamics that will have an impact and maybe some externalities on the players. Yeah, and I think one thing to note here that a lot of papers that came after that original MDA paper were very critical of the fact that it was kind of like deterministic and almost like waterfall style. And so the part of the framework that we're working on is also how you can actually apply this framework and feed empirical data back into it, right? So you do like a really quick and dirty prototype, you do some modeling, you roll it out in the field, and then you update, and then you update, and then you update. So you actually run experiments to get better data on what will work. Yeah, so another kind of like orthogonal direction is just thinking through tokenization more systematically. So, okay, people talk a lot about tokens, and they lots of times hand wave, what the tokens are for. Right, the tokens are for governance, or they're the access token for the system, to the currency. But I don't think there's like an infinite design space for what a token can do. I actually think there's like a very like limited set of things that like a tokenized right can give you. This is like a starting point for thinking about it, I think. And so I think the really exciting, I guess, aspect of tokens is that they take us beyond what like shareholder, like stock corporations have, which is a governance economic rights, into the ability to program complex access rules. And then another like misconception I see generally is that when people think token, they think transferable ERC20 or Bitcoin, or that maybe as of the last 2 years they'll think, oh, NFT, right? So this like collectible art piece that I can like send to anybody. But I actually think it's useful to think about the whole the spectrum of what we could call tokens as encompassing things that we wouldn't normally think about that aren't financialized, right? So you have a spectrum where you can code in restrictions on transfers of tokens or like block or prevent transfers entirely, like in the case of your passport. which is non-fungible, it's unique to you, and it doesn't have validity if you just sell it to somebody. And then on the top right quadrant, we have units that are fungible, so every one is like any other one, but they can't be traded between people. They wouldn't have the same significance, like Reddit karma, let's say, or Uber like rating score. And so continuing on the tokenization theme, I think the third side of this, that again, there's patterns that have taken off that people then just mindlessly copy, is how do the tokenized rights get distributed, right? So after we know what the tokenized rights represent, how we're going to actually represent them in data structures, and then we have to think about how people acquire these rights over time. What do they do to get them? And so there's lots more in the library on ways to do this, but this is just like a basic example looking at, again, Newton's swap. Okay, so that's a little sampling of some of the design methodologies we're looking at, and quickly I'll show you just snippets from a project we did with Gitcoin on modeling the impact of different mechanisms. So thinking how you can then take conceptual concepts like token staking, burning a token, right, like bonding curves, and token created registries, and then actually model the impact these different mechanisms will have in different values that you put into those parameters. What impacts will those have on your overall goals, on that impact that your system is trying to achieve, right? So if you're trying to prevent Sybil or capture value in your governance token, then you have to understand how the different variables will affect those outcomes. And lastly, I'll touch on the AI bot we're making. So this is a bot that's trained on the library, and we're constantly updating the library and then needing to retrain the bot. And when I say train, I mean run it on an embedding of the library. So it does a semantic lookup based on a query in the library to see which mechanisms are most relevant to the thing that you're trying to build, to the coordination problem you're trying to solve. And it might suggest a few mechanisms and then tell you examples of how it's been used. And then lastly, create a proto specification of how your mechanism overall will work, like a step-by-step of how the different primitives could fit together. And so this is one of those things that is very rudimentary right now. I can demo it if you'd like. But it just gets smarter over time as we have more contributors to the library and we have more empirical data, just basically plugging in all the case studies that have already happened in the space. And so this is uglier what it actually looks like. That was just a mock-up here. And so yeah, we can just ask it these sorts of questions, and it might grab the right entries from the library to suggest an overall protocol flow, the different participants, the key primitives that it's using. And this is just the first part of that, but we can take comments from the audience later. And yeah, so those are a couple of the materials that we're working on and putting out, and some of which are already out there. Now this is kind of where we're going and where we think the biggest need is for crypto, is in actually doing the experiments. So for example, with Gitcoin, we designed for them a Sybil detection game for Passport that lets various actors, like data scientists, stake GTC to submit lists of suspected bots and duplicate accounts. And then the smart contract will take the highest incidence over those and then slash those passwords automatically and reward the Sybil hunters who put that who submitted those accounts. And so that's great in theory. We have the prototype, it's public on GitHub, but we actually need to run tests on that, right? You're not just going to throw that into production and then potentially jeopardize the identities of hundreds of thousands of users. And so, some next steps, for example, with that project is to actually organize an experiment, put real money, real skin in the game, get beta Sybil hunters together, and then run these sandbox experiments. And so we want to do that sort of thing, not just with particular protocols, but then also, with communities, with organizations that are using crypto mechanisms already. And so we have the whole research roadmap there that we can talk on later. Design competitions, I think, is another useful modality. So kind of defining problems, maybe even outside of crypto, that we think mechanisms can help with, and then putting together individuals from teams that do mechanism design, understand the affordances of smart contracts to solve those problems. Let's say, for example, how do you prevent human rights abuses with mechanisms? What are some like problems in that space? Maybe you talk to Human Rights Watch and Amnesty and get them together, and then you bring the mechanism designers, and we can like workshop different solutions based on experiments that have already gone on in crypto. And yeah, don't have much to show on the others, but yeah, basically working this all into like an overall curriculum. And then, like I said, doing these experiments in the field, not just with protocols, but with communities through established research methodologies. And these are some of the specifics. I may have mentioned a few of them. These areas where we think there's like low-hanging fruit, where we can put in like a little effort in the next few months and actually come out with solutions that move the ball in these like kind of difficult problems that maybe people in the space have gotten a bit lazy on and just like moved past because the crappy solutions work well enough for the established players. And we can dive into any one of these that people are interested in after. Yeah, it's just a bit more about where we're going, very, very vague and without actual dates, so that I can't be held to account. Yeah, and that's it. I wanted to leave as much time as possible for questions.
Thank you very much, Rory. Who will be the first one for the questions? Towards the end. There is another hand. So we have to go through.
Hey, I was actually really curious about on the list of short-term projects. Thank you. The Harburger tax licenses. Can you say anything about who's working on that? Software licenses, what I assume.
Yeah.
What?
Yeah, definitely. So how many people here are familiar with the concept of a Harburger tax? About half the room. It's actually Seth and I, for ETH Berlin 2018, did a project on like Harburger tax ad space, and so this is a throwback, shut up. But yeah, they kind of died in the space since then. Like Glenn Weil wrote about them in Radical Markets, and Vitalik said they were cool, and so ENS did a prototype of selling address space through Harburger taxes. And then I don't think anyone ever used them beyond like some art projects. Which one? FX Hash? In an NFT? Okay, awesome.
Or orbs as well. Orbs.
Orbs, yeah. So I have orbs in the library actually as an example of initiative hardware. Yeah, so I'll explain it really quickly. So it's like this auction mechanism where you have some property and you set the value that you actually value it at, and then you get taxed at some percent of that over some frequency. But the catch is that anybody can buy the item from you at the self-proclaimed price. And so it incentivizes you to like note the true value that you value the asset at. So it was first proposed in the context of housing because property tax is this really like arbitrary institution where like a assessor comes and like decides how much your house is worth and looks at the previous purchase price. And anyways, it's just a very inefficient market and allows like people who pull lots of capital to just sit on lots of property and keep it idle. And so this isn't meant to be an incentive mechanism to prevent that. So anyways, back to the question. Yeah, I think that kind of mechanism is probably going to be hard to apply to like people's houses, but we could start to apply it to more like virtual goods where there's these like distribution problems. For example, intellectual property, right? So this is one of these spaces where you have lots of innovation, like in Creative Commons and different like open source licenses. But how could you actually take something like patents, right, and then issue the ownership of the IP as a Harburger tax, so that you don't become like this perpetual or like whatever it is 20-year monopolist with like the ability to withhold your invention from the market or just like sell it to like sort of prices. How do you do a more fair pricing mechanism for IP, basically, or copyright? And then the resource use idea is like environmental resources. So Eleanor Ostrom is like examined in depth like common pool resources like timber, fisheries, and things like this. And there's various licensing schemes to limit the amounts that these resources can be extracted from, so that it's below the replacement rate of the ability of the resource to provision itself. So anyways, you could program those kinds of constraints and conditions into some sort of Harburger tax just to have some more optimal allocation of the rights to use environmental resources that are limited.
Thank you. Any last question?
Yeah.
Or okay, not last. Sorry.
So this is a lot about mechanism design, and from the way you present it, you kind of imply that mechanism design is a thing that is absolutely a good thing for the world. You can almost mathematically prove this, and it's just a case of applying it in some ways. And I'm just wondering if there's any sort of naysayers or kind of like doubt about whether a mechanism designed world is what we really want, and what the drawbacks are. You know, I hear a lot of positive things about it, and when I hear so many positive things, I want to know what's the rub.
Yeah, no, I definitely agree with the skepticism, and there's definitely dark mechanism design, or like status quo enhancing or worsening mechanisms out there. And the two that come to mind that you're all probably very familiar with are like cases where there's coercion, where it's like a central bank digital currency, or it's like an orb device to scan your iris that's owned by a billionaire who controls our information, like creation systems. And so there's dark mechanism design. In one case, I think when there's coercion in the use of the mechanisms, and so you don't have an opt-out. I think the beauty of like the way I use mechanism design is that these are optional systems, right? So that's a key piece, right? The ability to exit. Of course, network effects can have implications here, but in an open source world and in like a multi-chain, inter-chain world, these concerns can be mitigated. So yeah, I think that's one area to like be careful of. Like, don't help authoritarians design mechanisms that they can coerce you to use. Another, which I'm sure we've all been victims to some extent or another, is like these like super obfuscated mechanisms that are just like Ponzi schemes with extra steps. Right, so you can be a very good, and some of the best mechanism designers I know have like unwittingly contributed to like very complex Ponzi schemes that they didn't understand were Ponzi's, but the people involved didn't understand. It doesn't literally have to be a Ponzi, but something that like, doesn't have fundamental soundness, but there's so much hype around it that people go in anyways. And so yeah, I think we need better mechanism design because this is, you know, whether we like it or not, authoritarians are going to use it and scammers are going to use it, right? So I think we need to have a more robust understanding of the design space to know what's going to lead us towards better outcomes, potentially post-capitalist ones, or ones that can make us flourish more or mitigate existential risks, versus mechanisms that are going to exacerbate this.
Cool, thank you, and thank you for the talk. Really, really interesting.
Yeah, I'll just add something there. Not really a question, but rather kind of to add on kind of like how it could go wrong. Yeah, just when Ori was talking about kind of Ponzi's with extra steps, like Terra, Luna might be an example of that. You know, maybe something where you're talking about bad outcomes or like second order, third order, nth order effects. You might say something like BitClout or Friend.tech. One could easily see this leading to dystopian outcomes. So yeah, mechanism design can establish a game, but this makes me think about kind of like the Jeff Goldblum and Jurassic Park thing, like just because we can, should we? You know, and like, can we think about like the intention of these systems and really design for what outcomes we want?
Hi there, super interesting talk. So I think like right now we have a lot of spare block space which a lot of L2s are trying to sell, and we are also seeing a lot of fragmentation in the space. Like as a dApp, if you build on one chain, it's hard to kind of work with other chains and whatnot. So I was wondering kind of if we can go to the slide of future research directions. I was wondering like how many of these kind of primitives that you're trying to build on like identity and fundraising mechanisms and whatnot would be chain agnostic, able to work across chains with the public key or something else, versus those that are specific to L2 or any particular chain.
Yeah, I would say almost everything we're looking at is chain agnostic. It's just working with the concept of humanity now has smart contracts. What can we do with them? And you know, of course, mechanism design can go below the layer of smart contracts. You know, when designing smart contract platforms themselves, L1s, that's what we're looking at. There is some useful analogs we can draw from those. For example, the dynamic parameter setting mechanisms of Bitcoin's difficulty algorithm or Ethereum's block space algorithm, we can like take those and transpose them to the smart contract layer to like determine the values of a parameter of a governance system, for example. So I think you can learn a lot from the base layer, but we're kind of agnostic in that sense. And I think there's different people working on the problem of bridging mechanism, or rather bridging dApps and instances of mechanisms between chains, like sharing data or liquidity across chains.
Hey, really amazing collection, great ontology, probably one of the best I've seen. I was wondering if you've given some thought to, in this community, there's plenty of people shilling, their protocol, their DAO. It all works great, and we're not really looking at when it fails or when it goes wrong. And in terms of mechanisms and a collection of that, propagating mechanisms that I won't say don't work, but aren't well applied. Have you given some thought to that and how that applies here with this collection?
Yeah, I mean, one of the most fun aspects of this project is to document the failures. And I think that's one of the areas people should look more deeply at in order to learn what to build, is looking at what not to build. Right, so we don't have extensive case studies at the moment, most of them are a few sentences, but that's a big part of the learning that we want to be a part of is, for example, curation mechanisms. People were really into that in like 2018, 2019, tons of blog posts, tons of proof of concepts, like not many of them worked, right? Why is that, right? Like we need to understand that. We can't just we're not just promoting, oh yeah, use TCRs, use curation markets. We should understand why the ones that were tried worked and didn't work. And it's hard in many cases because a lot of times it's dependent on exogenous factors like the personality of a founder or regulators or the market, hype cycle. But yeah, at least we can try to document what worked about it, what didn't work about it from a mechanism perspective. Yeah.
Okay. Coming.
And how do you manage to finance this sort of collaborative and open research and initiatives?
Yeah, good question. So right now we work on a project-specific basis, but the aim is to avoid becoming a mechanism design consultancy that's designing mechanisms, because there's plenty of token engineering consultants, mechanism design consultants, and we want to chart a space that's more advancing the science of mechanisms and the design methodology of mechanisms. And so there's a few ways we're going about that. One is one project, many supporters, right? So in Gitcoin's case, it was our first project, so it's just Gitcoin and this Sybil detection and public goods token research. But for a lot of the research topics we've mapped out, we have several partners that could collectively fund any one of those. And then the other modality I would mention is more so training individuals, companies, communities, and how to do mechanism thinking, right? So more so almost education and training and coaching. As we're making the resources, we can then be working hands-on with people to shift the way they think so that they understand the design space better in the work that they're doing. So rather than just building a mechanism for someone, handing it to them and saying, here, code it up, more so doing a training and support in that way. And then another.
Does it help finance?
Yeah, this is something that people need. And so one approach is to create a useful service for the market. And then the other is to partner with existing research institutions, nonprofit foundations, donors, and then corporate sponsors, protocol sponsors in some case, who are interested in the actual mission and see some value for the kind of supporting that. So we're doing this combo. Thanks.
Oh, last question, Rebecca.
I can ask.
No, we need that for stream.
Can you quickly elaborate on AI trading frameworks?
Yeah. So I guess this is broader than training. Just generally a lot of the problems with AI governance, some people call it AI safety. Basically the problem of compensating and recognizing the provenance of data that's used in training, and so there's been different models proposed that would use like cryptography in that flow. And then when it comes to AI, yeah, another model is just like people exposing clusters of GPUs running, like using models, right? So basically the open source AI problem where either you use a proprietary, like centralized solution, or you have hardware and you run local models, open source models locally. And so there's like these concepts of like GPU DAOs and these like local AI clubs, and basically looking at how we can have mechanisms that can have the crowd sort of like rival the behemoth, the monoliths in terms of AI. There's a few other sides to the AI question that are not popping to mind, but yeah, it's a very one.
Yeah, we can talk it later.
Cool.
Thank you so much already. A big round of applause to all.